Hi guys. Happy Friday. Did you guys ever notice how many, I don't know, maybe you can't see it. Yeah, you can see this in the chat. You can put emojis, and there's like 200 pages of emojis, different options that you can put in the chat. Well, maybe not 200 pages. It's crazy. Yes, and some of them are very inappropriate. Well, happy Friday, guys. So we don't have too much to do today. I want to finish off what we were talking about, but I don't want to start anything new. So we'll finish up pretty early today. So we'll do that, and where is everybody? How about we wait a few minutes? There's only 4 people on here. Oh my gosh. Next week is week 10. Week 10 of the semester. We're doing it. We're making it. And we haven't been shut down yet. Oh boy. I was telling my class this morning that I've never been more excited to get a shot than I am right now. I cannot wait to get the COVID vaccine. And so is my kids, my daughter, because I promised her that, I think I told you this, that once we get our vaccine, and my son too, once we get our vaccines, we can go to Chuck E. Cheese again. So that's going to be a big day in the Groff family when we can go to Chuck E. Cheese again. And hey Alex, hey, my bees are doing great. They're eating lots of sugar syrup right now to beef up for the winter. And I also told them that I told my daughter that we could go roller skating at the roller rink. All these things that involve lots of people in small spaces. And we're going to go to the farmer's market in Pennsylvania and get freshly made Mennonite Long Johns. And you might say, what's a Long John? Oh, it's only the most delicious donut you've ever had. And they come in all different flavors. And they're filled with they're like long, like this. And they're filled with cream, white, chocolate, peanut butter, anything you want. But the place is packed. So I feel like, things are going to be just like amazing in the next couple months. Let's cross my fingers, hoping the vaccine comes out. Alexis, I did get your email. I have no idea. I have to look at it. Maybe we can look at it next week in lab. Oh, James, you had an issue with 7C as well. Was it the same issue? You guys probably don't know. So Alexa was referring to a specific error code. Maybe Alexis, put a description in the chat, and James, you can see if it's the same problem that you are having. All right. Well, anyways, let's finish off this work we were doing last time. There we go. Okay. Yeah, remember my computer crashed last time? That was fun. So I had to redo a lot of the work that we did last time. But it wasn't that bad because, it's an interesting example of how ArcGIS handles data. So anytime you apply a function, a geospatial, or a tool from the geoprocessing toolbox that creates a feature class, that feature class gets saved to the geodatabase, the working geodatabase, automatically. So when my system crashed last week, all my maps and stuff went away, but the feature classes that we had created, all these raster feature classes that we had created from aspect, hillshade, and slope, were still there. So I just had to put them out here on the map again. All right, and we were almost finished. We were almost finished with this. We were working in Model Builder to try to take these reclassified, well, maybe I'll delete this for a second, and let's validate this. Looks like it, and I'm gonna run this, and this will create 3 feature classes. So it's gonna reclassify hillshade as reclass hill, slope as reclass slope, aspect as reclass. Maybe I should check these to make sure these are all the same. That looks right. That looks right. So we specified these classes as being 0s or 1s, depending on the values in these hillshade raster, slope raster, and aspect raster. So let me run this, and you can see it's running. What's running is the red part, and then when it's all done, you get the shadow effect. So it's all done. Okay, it created. Let's refresh this. There they are. 3 new feature classes here, are data sets, raster data sets, and they're all in my geo database. So let's put them on my map here. Let's drag them out here. Yes, build the pyramids. Pyramids are a tool or a feature that allow rasters to render quicker when you're viewing them on a map. So I'll turn all this other stuff off for now. And so what you're seeing here are, this is the reclassified slope data, and a slope value of 1 was suitable. That was actually a percent slope of 14 or less. So all the green pixels are places where the slope was suitable, and all the purplish, that's a pretty color. I'd call that mauve. All the mauve pixels are places where the slope is too great. All right, but the color coding here isn't the important thing. The important thing is there's now 2 classes. We had taken a variable which was much more continuous from 0 to 100 and reclassified it as 0s and 1s. And then we did the same thing with the hill class. So here, places that have purple pixels, purple corresponds to class 1, and that's suitable slope, suitable hillshade. Sorry, and the class that's this like yellowish brown is not suitable hillshade. So these are places that are shaded too much. And then this class right here, 0s are bad, 1s are good. So this is the aspect ratio. This is whether or not something points sufficiently south or southeast or southwest. And so we can get an idea of the property polygon. So right now the property polygon is on, and then these planning sites, these possible sites for new fields are on here, polygons for them. So if we turn one of these on, you can see 1 is good, 0 is bad, 1s are green, and 0s are mauve. So you can see where good fields are and bad fields are, good possible locations are, based on slope values. So this is based just on slope. This is a really good option right here because it's mostly green, and this option right here is pretty bad because it's mostly mauve. So there's too much slope here, and so you can eyeball it, the hillshade as well. So here purple is good, purple's 1s, and this brownish color is 0s is bad. So this field again is really good. It's got good hillshade values, and this field right here is bad. And now let's go to aspect ratio. So again, 1s are good and 0s are bad. So again, this field bad everything. Okay, so this is a good field. This is a good field. The green is good. The like pinkish color is bad. So I'm seeing that James and Alexis have different problems on 7C. James says my issue was with building the model in the selecting good zone section. My model didn't match the one depicted in the text. So James, you might be referring to when you did select by location. When you use the select by location tool in the model builder, you drag it out onto your model and it has 3 outputs, and in the text there's only 1 output. So that first output is the one you want to use, and the other 2 are we're not using in the case of this lesson, but they represent other aspects of the data that's created by that selection tool. For example, the last one, count, is how many features are selected by that select by location. So maybe that's one of the problems you were having. All right. Anyway, we got so we got these 3 different reclassified rasters, and with this last tool that we're going to use, it's called calculate. Where is it? There it is, Raster calculator. And we started working with this last time, and let's not do that. And everything crashed on us. But when you open this up, there's a little box here where you can put in an expression. And so let's do something a little bit different than what the text does, and let's just say that these 3 factors, hillshade and slope and aspect, are all sort of equally important. They're equally important, and that means we can make a weighted sum of the pixel values in these reclassified rasters. These guys over here. We can make a weighted sum of these pixels to come up with a grand sum and over all of those pixel values. Okay, so you can see it up here that the outputs of our reclassify tools are in here as variables that we can use. So if I double click there, that's what was not happening last time. It wasn't appearing down here, and then my system crashed. But if we want everything to be on equal footing, we can multiply each of these. There's 3 of them, so multiply each of them by 1/3 and add them together. Oh, come on. There we go. Maybe I'll get rid of some of these spaces so we can see everything here in a line. All right, and I used the analogy last time with comparison that what I'm doing here is exactly like what you would do if you're calculating a weighted sum for your grade. You have test scores, that's 25% of your grade. Homework, that's 25% of your grade. Lab score, that's 25% of your grade. Projects, that's 25% of your grade. So you take each of these individual grades, multiply by 0.25, and add them together to get your total grade. So we'll make the output here called suitability. analysis raster, something like that. Okay, so now everything's connected up, and let's validate things, and then I'll run it. Running, so you can see whatever's running currently appears red on the model builder. And it's done. Okay. So now in my catalog, let me refresh my database. I should have suitability analysis raster, and there it is. So let's pull that out here, and I'll put it underneath the planning fields. Yes, build the pyramids. And there we go. Okay. So the color is, so the numbers here are between 0 and 1, and it's a little hard to, let me change the planting sites color to something different so we can see it. I'll make the planting sites blue, a nice blue. There we go. Well, that's still a little hard to see. I don't know, it's a little better. Alright, and for my suitability analysis, let me actually look at the histogram for this. That's kind of cool. So what we're seeing here is there's only 4 possible values for pixels in this composite, the suitability analysis, and this makes sense to me because it's being calculated from these underlying rasters, and if all the rasters are 1, pixel value is a 1, then the weighted average is 1. If 2 of them are 1 and the other one is 0, the weighted average is 0.666, and if one of them is 1 and the other 2 are 0, the weighted average is 0.333. And if they're all 0, the weighted average is 0. So that makes sense to me. The color, though, doesn't really make sense to me. I wonder if we can do unique values. Oh. Let's try different. This is behaving a little weird because I would expect there to be some grayscale pixels, not just white or black. Alright, it's not super important here. But the composite analysis here gives us the same result. Like when we looked at the individual when we looked at the individual fields, this field and this field right here look like really good candidates, and that's true even when you weight all 3 factors, hill shade, aspect, and slope. This field and this field look like good candidates, and this field looks like a bad candidate. So if you wanted to come up with like a numerical answer for which field is the best, I don't know, maybe this isn't the best thing because there's other factors too, like how close is a field to needed infrastructure, irrigation, electric, roads. So there's other factors that aren't considered here, which might eliminate some of these potential fields. But you could do something like you could use the polygons for the potential planning fields to calculate the average pixel value inside, and or average and standard deviation, and so that gives you a summary statistic for how suitable the entire field is, the entire potential field is based on the pixel values that you have in your suitability analysis. All right, so let me see. So that's the end of that material. And let me look at your comments here, see if you figured anything out. So yeah, Alexis and James, you're having separate issues. Alexis, I guess I'll take a look at it next week. You're getting a specific error code, which is hard to give you any insight to without seeing it be produced. Okay, so to finish up here today, and then we'll finish early, I want to talk about your end of semester project. And so I'm formulating the parameters of this project. I'm thinking about this, and one thing that I've arrived at is, well, let me back up a second. The goal of the end of semester project is for you to, one, explore data that you find interesting, okay, and that means you're going to go out into the world, onto the internet, more than likely, and you're going to locate geospatial data, and this data is going to be the input into your project. And so I've decided, so you want to work on something that you're interested in, so you find data, explore data that you're interested in, and then second, it's a chance to show off your GIS skills, your GIS skill set. All right, and the ultimate goal of the project is for you to use data and a GIS to answer some question, a question that you formulate. And I've decided that the question that you formulate has to be a question that requires at least two separate input data feature classes or shapefiles in order to answer that question. And you're going to have to apply some analysis tools from your toolbox to answer that question. So let me give you an example of something that would fit this definition. Okay, and an example that would fit this definition is one of the questions that's posed in the second lab practical, which is, well, I guess both of them would fit this criteria, but let's just use the second question. The second question I presented you with was, how many people live within 50 miles of the Appalachian Trail? And you need at least two feature classes to put into your project to answer that question. You need a feature class that represents the Appalachian Trail, or has a representation of the Appalachian Trail as a polygon. And then you need a feature class that has information about population. And you need both of those things, and then you apply some geoprocessing tools to create what's called them derived feature classes. The feature classes that are the outputs of when, like, for example, you use the buffer tool, it creates a feature class, which is that is a polygon representing the buffered extent that you specify. So a question like that would be suitable because you need to have at least two separate feature classes to answer that question. Let's see. So what would be? Here's an example of a question that is not suitable, would not fit that definition. Which county in West Virginia has the highest poverty rate? And that wouldn't fit the bill, because in order to answer that question, all you need to have is data about the poverty rate in each county in West Virginia, and you can make a map, and like bright red is high poverty, and then one county is the brightest red of all. That only requires one data set to answer, and you don't have to use any analysis tools in the GIS to answer it. Okay, so that's not sufficient. That's not a sufficient thing. Okay, but this this pretty much defines my global expectation for what these final end of semester projects are going to be like. The specifics, the outputs that I want you to generate, I'll formulate that for you and put it in an assignment like I do for the practicals. But it's, as you can tell, it's very free form. You get to choose the data, you get to choose the question, you get to figure out the steps that you're going to go through in order to analyze the data and answer the question. But in this framework, the question you ask, you have to ask a question that's going to require at least two separate feature classes to answer. These feature classes can be point features, they can be line features, they can be polygon features, they can even be I was going to say that you could even use raster data, but I think I'd like to constrain the scope here to just vector features. The analysis is carried out starting with a foundation of two data sets that are vector features, points, lines, or polygons. All right, and of course those features have attributes associated with them, potentially many attributes, but those attributes like poverty rate, population, are attached to the features, all right, and part of the analysis. All right, so that's the global vision. All right, we're going to be in week 10 next week, so we have 5 more weeks of the semester plus final exams, and one of those weeks is remote completely, which isn't really going to be that different for us. But during that week, we won't be doing things in a standard way. That's the week after Thanksgiving. All right. So that's all I got for today. Does anybody have any questions before we call it a day? It'll soon be time for me to put my bees to sleep for the winter. In about a month, I'll have to I replaced their inner cover with a piece of rigid foam insulation to help keep them warm. And I gotta take I'm treating them for varroa mites right now. I'll take that treatment out, make sure they have enough honey, and say good night, bees. And if I get a really good day in the winter, I'll open it up and see how they're doing, making sure they have enough food. All right, I don't see any questions, so you guys have a great weekend and enjoy fall. It's just such a wonderful time of year. It's magical. I love it. It's cool in the morning, cool in the evenings, and we've had these just awesomely warm days. Good sunshine, beautiful colors. Enjoy it. All right. I will see you guys on Monday.